Oftentimes, you blame your own coding practices and feel yuck about slow-running Python scripts and apps. You debug your code, you optimize, but yet you feel that you are controlled artificially by the Python interpreter. Well, yes and no. This isn't a bug, but a feature. The mighty GIL, the Python Global Interpreter Lock. Let's dive deep into it. Official Python documentation states that GIL is a mutex that allows only one thread to control the Python interpreter at a time. This means that even in a multi-threaded Python program, only one thread can execute Python bytecode at any given moment. The GIL is designed to prevent deadlocks and ensure thread safety, but it also means that CPU-bound Python programs are effectively single-threaded. Oh, that's heavy stuff. Let me simplify it for you. The modern computer CPUs introduced multi-core parallel executions and gigahertz of power to run your code faster than before and do more in less time. Now, to utilize these cores one by one won't help you, as it will be limiting the optimum power of the multi-core system. So your first bet will be on the threads. Because of GIL, as the code is executed, it has to run sequential instructions, and many times they branch out to perform multiple jobs in a linear fashion. Like you are calculating salary from one CSV file, and then you open another CSV file to calculate the payroll. So the threads have to start, finish their individual jobs, and they perform join operation at the same time, uniting their results or signal to the main thread. The GIL is essentially Python's way of saying, one thread at a time, please. It's a mutex, mutual exclusion lock, that protects access to Python objects, ensuring thread safety in Python's memory management. Without it, your program might become a wild west of dangling pointers and memory leaks. In conclusion, GIL is essentially beneficial to keep integrity of the runtime, avoid deadlocks, and makes code more predictable at the loss of limiting the process using single thread and single core. There are ways to overcome these limits in Python with multi-processing library to run your functions in a new process utilizing all the cores. We will cover multi-processing in detail in another video. Another topic of discussion is to use G-event-based implementations that can run code in async state to overcome I/O waits. So, this is Python GIL. If you like these videos, please subscribe and share. In case you want to know any other topic in detail, let me know in the comments. Thank you, and have a great day.
Aldous.